Saxon Math 8-7, lessons 108, 109, and 110. Lesson 108 is nothing really you guys haven't dealt with before. You're given a formula, and instead of just solving for something, they're asking you to solve for something when you know the values of the other items. So here we're using the formula A equals B times H to find B when A equals 20 and H equals 4. Now you probably recognize this certainly. That is the formula for the area of a parallelogram or a rectangle or a square. Area equals base times height. So we're trying to find B. So the first thing we want to do is just solve this equation for B. So I have A equals BH. I want to get B all by itself, so I'm just going to divide everything by H. So that means we have A over H equals B, because H divided by H is just 1. And if you prefer, I'll just write that, what we call the left-hand psychosis there, put the thing we're trying to find on the left side. So B equals A over H. Well, now we know that A is 20, so I'll plug that in for A. And we know that H is 4. I'll plug that in there. That means that the base is equal to 20 divided by 4, which is 5. There you go. There you go. So that's all you're asked to do for this section, really. You have another one here. Use the formula A equals 1/2 BH to find B when A equals 20 and H equals 4. So again, I'm going to solve for B first. So I get A equals 1/2 BH. So let's start with the 1/2. I want to get rid of that 1/2. Well, 2 times 1/2 is 1, right? So if I multiply both sides of this by 2, over here I get 2 times A, or 2A. I get 2 times 1/2, which is just 1. So all I'm left with here is just BH. And just as above, I want to get the B by itself, so I'm going to divide by H. So now I have 2A over H equals B, or B equals 2A over H. Now again, we know A is 20, so this would be 2 times 20 divided by 4. Well, it looks like that's going to be 2 times 20 is 40 divided by 4. In this case, B equals 10. All right, splendid. Now, here we have the formula F equals 1.8 C plus 32. And this is the formula for converting from a Celsius temperature to a Fahrenheit temperature. Celsius to Fahrenheit. So here we're asked to find Fahrenheit when Celsius is minus 40. All right, cool. So F equals, there's no solving to be done here because it's already solved for the value we're trying to find, in this case F. So I'm just going to write 1.8, and then for C, I'm going to plug in the value minus 40, and then plus 32. So now it just becomes a question of arithmetic, doesn't it? Yes, it does. All right, well, 1.8 times 40, well, that's the same as 18 times 4. The 0 will cancel out because of the 0.8, but you got to calculate if you want to do it that way. But you can easily do this in your head. 4 times 10 plus 4 times 8, it's 72, isn't it? Yeah. 1.8 minus 40 is 7 times minus 40 is a negative 72. So plus 32. Well, 72 plus 32 is a negative 40. And you think, uh-oh, must have made a mistake. No. Minus 40 below is the temperature where the Fahrenheit and Celsius scales are the same. Yeah, that's the only point where they both read the same temperature. So next time it's 40 below outside, you can go out and, just have a little fun thinking about that. Oh, it's minus 40 Fahrenheit, minus 40 Celsius. Same thing. All right, so that's lesson 108. Again, nothing really new here. Just solving, plugging in, then doing the arithmetic. So that should be no problem for y'all. Okay. Excuse me, that was just a normal cough. All right. Lesson 109. There's a couple things going on in 109. We've got these problems here which involve x squared terms that we need to solve. And then we've got some problems that are just what we call story problems, where you have to read the English text and convert that into the mathematical symbols. We've got a couple of those. And then we've just got a basic solving. Again, this is another squared term. So let's start up here with this one up here. 3x squared minus 8 equals 100. We're trying to solve for x. So first we want to do is we want to get this 8 over here. So we're trying to isolate the x squared term. So since this is a negative 8, remember, I can just move it right across the equality as long as I change its sign. So I can just write this as 3x squared equals 100 plus 8. A negative 8 here, when I move it over, becomes a plus 8. All right, well, that means 3x squared equals 108. Now, to get the x squared all by itself, we divide everything by 3. So x squared equals 108 divided by 3. You can do that in your head. 3 goes into 10 3 times with a remainder of 1. Put a little 1 right there. 3 goes into 18 6 times. So x squared equals 36. All right. Now, since this is squared, that means I can solve for just x by taking the square root. And remember what algebra says, I can do whatever I want to both sides as long as I do it to both sides. So I'll take the square root of this side. That should equal the square root of that side. The square root of x squared is, of course, x. And the square root of 36 is 6. But wait, there's more. This expression here, x squared equals 36. Let me write that again right there. At this point right here, okay, we can solve that by taking the square root of both sides. But there's a better way to solve this, which you're not going to learn for some time, which explains why there's two answers to this. There's two answers to this for a couple reasons, because the exponent on the x term is a 2. If the exponent on the x term were a 3, we might expect to see 3 answers. 4, we'd 4 answers. But all that matters here is that whatever x is, the x squared means I multiply it by itself. So what number multiplied by itself equals 36? Well, 6 does, 6 times 6, but also negative 6 does. Minus 6 times minus 6 is also a 36. So when you solve an expression like this, where you have x squared equals something, you should always get two results, plus and a minus. So x squared equals 36 results in x equals plus or minus 6. Now, don't be swayed. If I just ask you what's the square root of 36, in other words, we're solving it outside this expression here, by definition and agreement, the square root of a number is positive. So the answer here would just be 6. But when we have x squared equals 36, we can get two choices here. So yeah, that's the key. That's the point of a part of lesson 109, is when you're solving something that x squared equals something, you should get two answers, a plus and minus result. All right, so let's look what happens over here. We have x squared plus x squared equals 12. Well, these two are similar terms, what we call like terms. We can combine them. This says 1x squared plus 1x squared. So that's 2x squared equals 12. I want to isolate the x squared, so I'll divide by 2. 2x squared divided by 2 is just x squared, and 12 divided by 2 is 6. So now we have x squared equals 6. Well, that means that if I take the square root of both sides, x will equal plus or minus the square root of 6. 6 is not one of our perfect squares. Remember, you've memorized all your perfect squares, at least up through 15. 6 is not one of those, so we're just going to leave it in that form, square root of 6. That's the best form to leave it in. That would be an exact value. So x equals plus or minus the square root of 6. So when we have this x squared term, we're always looking for two answers, plus or minus root 6. Yes, excellent. Okay, C. 5 less than twice what negative number squared is 157? All right, so what are we looking for? We're looking for a number. So we're looking for that number right there. I'm going to call that number n. Okay? Now it's negative. More on that in a moment. And if I square it, Oh, 5 less than twice what number squared? Good. 5 less than twice what negative number squared? So that would be twice what negative number squared is 2n squared, and 5 less than that would be minus 5. Is, anytime you see the word is, that's an equal sign, is 157. So the way to really get around these, navigate them well, is figure out what you're trying to find, where that is embedded in your statement, and then work out from there. So we found the number, and then we saw that they wanted the number squared, and then it was twice that number, so that what gave us the 2 times, twice, and then it was 5 less than that. So find the number you're looking for and then work outward from there to get the result of the full equation. Now this becomes an expression like up above. We're just going to solve for n. All right, so let's see. We have, I'm going to add 5, so we have 2n squared equals 157 plus 5, which means 2n squared equals 162. There we go. Now divide everything by 2. 2 divided by n squared is just 2n. 2n squared divided by 2 is just n squared. And 162 divided by 2 is 81. All right, you guys have memorized your squares. You can recognize that straight away as a perfect square. If n squared equals 81, then n can equal plus or minus 9. Now, be careful. In this example, they specifically are asking for the negative 1. Sure, there's 2 answers, but they only want the negative result. So to answer this question properly, we're just going to say n equals negative 9. It is certainly true if you plug 9 in there, you'll get the same result as if you plug negative 9 in there, but they're only asking for the negative one. So make sure you answer what is actually being asked. All right, similarly here, if the product of the square of a positive number and 7 is 21, then what is the number? Okay, so we have a number. All right, good. And we have the square of that number. So again, I'm going to let that number be n, and we're squaring it, okay? Now we have the product, the product of the square of a positive number and 7. Okay, so that means we're multiplying our number by 7, the product of a number and 7. That means 7n squared is 21. If the product of the square of a positive number and 7 is 21, then what is the number? Okay, so there we go. Now we are going to divide by 7. So n squared equals 21 over 7. We all know 21 over 7 is 3. N squared equals 3, so that means n is equal to plus or minus the square root of 3. Now they're asking for only the positive one, so our official answer for this problem will be n equals the square root of 3. And again, you could figure out what that is on your calculator, but that's a better way to write it, just square root of 3. Okay, good. E here, we just have a fraction equals a fraction, which means we know that we can cross multiply to solve that, can't we? Sure we can. So this would say that w times w should be equal to 4 times 9. All right. W times w is w squared, and 4 times 9 is 36. All right, we already know that, don't we? That means w equals plus or minus 6. All right, so when you memorized all your perfect squares, that's going to come in real handy for you for this lesson. So there we go, lesson 109. And that brings us to lesson 110. Lesson 110 is about investing money and what happens when we have percentages that grow. All right? Now, your book teaches you a method of figuring this out where you set up the initial equation and then you keep pressing the equal sign or the multiplication sign on your calculator, whichever one is going to give you the desired result. And that's all well and good because the problems in your book only have you, compound the interest for a few months. But here, when Sarah turned 21, she invested $2,000 in an IRA. That's an individual retirement account that grows at a rate of 10% annually. What will be its value when Sarah turns 65? Well, golly, that means it's going to be lying in investment from the age of 21. So that's 44 years. So that means if you do this on your calculator, you're going to have to press your calculator button 44 times. Don't do that. There's a better way to go about these, and you might as well just learn it right now. It's just a formula. You just plug it in. And the formula can be written a number of ways. By that I mean some people use different letters for everything. But we're just going to do it this way. P, which would be the principal, that's the amount of money you have at any given time, is equal to the investment you make times 1 plus the interest rate. I will just use R for that, to the power of T, where T is the time that you're going to leave that invested. So P is principal, I is the investment, R is the interest rate, and T is the time that you're going to leave an investment. All right. We're asked to find out what its value. Well, that's the principal. We're asked to figure out what P is. Okay. So we're just going to play P equals the interest, the investment rather. So that's $2,000. Look at that, $2,000. So 2,000 times 1 plus R. Well, R is 10%. Now make sure you write that as its decimal equivalent. Don't put 10 there. We'll put 0.10. That's the decimal equivalent of 10%. To the T, well, it's going to sit there for 44 years, isn't it? Times T, which is raised to the 44th power. Now, you might look at that and think, holy guacamoles, we're going to take something and raise it to the 44th power? What could that possibly be? Well, before we figure this out, I want you just to guess. What do you think you would wind up in the bank is if you invested $2,000 at 10% interest and you just didn't touch it again for 44 years? How much would you wind up with at the end? What do you think? And I'm telling you right now, 10% return on an investment is really good. You can't go to your bank right now and get something that's going to give you 10% annual interest. So knowing that, 44 years, how much do you think you'll wind up with here? Well, let's figure it out. And here, you're going to want to get a calculator. So I'll be using my Illudium Q36 space modulator. So we want to say, I'm going to start here and work out. You guys can type it in your calculator, however it works best for you. So I'm going to say 1, and I'm going to point 1 and add those together. Well, that's 1.1, isn't it? Now I'm going to raise that to the 44th power, which on my calculator is done right there. Where is it? Right there. Yeah, right there it is, right there. Pow! And then multiply that by 2,000. All right. That looks like that's going to come to $132,528, and we'll just give it 15 cents there. All right. Is that what you guessed might have happened? I would think a lot of people would think they would have a lot more money than that after 44 years. Yeah. And it's like the less than a cost of a house. 44 years. Yeah. Investments often don't grow as quickly as people imagine they will. Which should tell you something too. When you're working one of these problems, if you wind up with this astronomical number, like, oh my gosh, you just earned $3 million, you almost certainly have done something wrong. But there's our formula right there, and we're just going to plug it in and solve it. We don't have to press the equal sign like your book says, 44 times. We're just going to use this formula right there, right there, right there. All right, nifty. Now, a couple things This ability to take something and raise it to, say, the 44th power, on your calculator, it'll be different. My calculator, I have a button that actually reads and has actually on it. There's my button. It says y to the x. So I just plug in the y value 1.1 and I plug the 44 and just tell it to do that. On your calculator, a lot of the newer calculators will just have a caret symbol. So you'll just put in, the 1.1 caret 44 equals. And you might have an x to the y. It varies, but there'll be some way on your calculator to do that, raising to any power you like, in this case 44. So tinker around with it, make sure you understand how this works. You should get that answer, then you know you're doing it right. Okay, all right. So that brings us to example B here. Sam deposited $6,000 in an account paying 8% interest annually. After 8 months, Sam withdrew everything. How much money, I'm missing a word there. How much money there it is. Anyway, swap those around. How much money did Sam withdraw? And secondly, what fraction of a year's interest was earned? All right, I have a couple problems with this problem. And first off, let's do it the way the book tells you to do it. All right, so we're going to get 8% interest annually. Well, if the money laid there for a whole year, you'd get $6,000. And then you'd get the interest, which is 1.08. Because remember, that's like 108%. The 100% includes your initial investment. And then we're going to put 8% on top of that. 108%. So if it sat in the account for a year and then you withdrew it out, you would get $6,480. So you'd make $480 in interest that year. Right? But your book says then, well, since you're withdrawing it after 8 months, then really what you're going to get is 480. You're not going to get the full 480. You're going to get 8 months out of 12 months worth of that. All right? Well, 8 out of 12, what is that? 4 3/4, right? So it would be 480. So you're going to wind up with $360. So that's the answer for this problem according to your book. But there's a couple problems here. A couple issues, I should say. Okay? One is that if Sam invests this at an account that pays 8% interest annually, then if he withdraws it before the end of the year, he's not going to see one extra dime. He's just going to get his $6,000 back. He's not going to get any interest if the account is actually paying 8% interest annually. And this problem, like the other problems in the book, don't make it clear. Is this going to be just paid one time annually, or is it going to be paid, progressively over the course of a year? Well, that's how it's usually done. If you go to the bank and if you borrow money or you invest money, you're given an annual interest rate. It's called the APR, annual percentage rate of the loan or whatever. And so to say it pays 8% interest annually, no account does that. What they will do is they will pay an aggregate of 8% annually, compounded over certain parts of the year. Normally that's monthly. So this $6,000 would accrue month per month per month per month. The interest would grow per month. Okay? You could get an account that grows interest quarterly, which means it would just do 4 times a year. Every 3 months, you would increase your interest. You might get an interest rate that is bi-monthly, so it only does it twice a month. Could be biannually. Maybe it's only twice a year. But most of the time, it's going to be monthly. So that doesn't mean you're going to get 8% interest every month. Remember, this is your annual interest rate. So your actual working interest rate will be the 8%, which is 0.08, divided by the number of periods in a year that will compound So again, if it were compounding quarterly, I would divide this by 4. Biannually, I divide it by 2. In this case, I'm going to assume, as is most often the case in real life, that the 8% interest annually is actually compounded monthly. So the actual interest rate is going to be the annual interest rate divided by the number of terms that it's going to compound, which is 12. So what is that? 0.08. Enter. 12 divide. Alrighty. That goes out to 0.06. 66666. In fact, is it less than that? 10 to the minus 2, 1, 2. No, 0.06. 0.06. And there we go. There we go. All right. So that means our effective interest rate is 0.06. Now, when we use this formula up here, then, we're trying to find our principal amount. So our initial investment is $6,000 times 1 plus the interest rate, which is 0.06. All right. But now, T here is not the time. It really wasn't the time here either. It just happened to match. T is really the number of times that the interest will be compounded. So in this case, from 21 to 65, it will be compounded 44 times. In this case, if it's compounded monthly at that interest rate, and you're only putting in for 8 months, it's only going to be compounded 8 times. There we go. So let's see what that comes to. So 6,000, and I have 1.06. Enter that. 8. So I'm going to raise 1.06 to the 8th power. That is that. And 6,000 times. And I've made a horrible mistake. I'd like to say I did this on purpose to show you that. Look at that enormous number. That's way too large. Yeah, I made a mistake. Where did I make a mistake? I made it right here. Yep. That's 0.006. So let's do that again. So I'm going to take 6,000. I'm going to take 1. They're going to take 0.08. Divide by 12. Add those together. Good. See, I was off by a couple decimal places. Yep. Poor form. And again, 8 months, accrued monthly, so 8. So raise that, kapow, and multiply that. And there we go. That makes much more sense. So our principal will be $6,327.50. I'm going to round up 57 cents. So in a real life situation, in this scenario, you wouldn't get $360 interest. You'd get $327.57 over 8 months. Not quite what they're giving you. So I think the book's a little confusing there about that. But again, here's the interest rate formula. Here's just a formula for taking some investment at some interest rate for some amount of time. There you go. All right. Let me know if you have any questions about that, obviously. All right. A TV set regular price of $300 was placed on sale for 20% off. When the television still did not sell, the sale price was reduced 20% for clearance. What was the clearance price? Well, some people might look at this. Not you guys, other people. I just want to mention it. And say, oh, well, that must be 40% off then. But no, we can easily tell that's not the case. Let's say it was for sale price at $300 and it was on sale for 50%. Well, then it'd be $150. If they did 50% more, it's not 50% of $300, which would make the TV free. It's 50% off the new price, which would be $75 then. So you can't add successive reductions. So 20% off and then another 20% off does not mean 40% off. So this is going to be done much like these problems up here, only in reverse. We're starting with the $300. Okay, so first off, I want to find out its sale price. So I'm going to take my initial price and multiply that by, well, it's 20% off, isn't it? So that means the sale price will be 80% of the $300. So multiply that by 0.8. So 300 by 0.8, you guys can do that in your head, right? That's going to be $240. So it's put on sale for 20% off, which means 80% of the original price. So right now it's on sale for $240. And it's not selling, it's not selling. So then, you know what? Let's reduce it another 20%. So another 20% off would be the 80% of this value. So 0.8 times that. Well, we got 80% of 240. So what's 80% of 240? Let's see, that's going to be 8. I'm going to say that's $192. You know what? I'm going to check my result. 240.8 times 192. Why did I doubt myself? So the clearance price ultimately is $192. Yeah. There's several ways you could set this up. Again, like these up here, we're only reducing it twice, so it's just easy just to figure it out and then figure it out and get the answer. But we could have done this just in one step if you wish. I could have taken the sale price, or the original price, which is $300, and I'm going to subtract from that the sale price times the reduction, well, not the reduction, times the 80% value. And since we're doing it twice, we're going to raise that to the second power. Okay, so I would get 300, 300.8. Wow, 192. What do you know? There you go. All right. You know what? I made a little mistake right there. What this value here is 192. What I should have written, apologize for this, but let's just fix it right now, is 300 times the reduction. I believe that's what I said, then I corrected myself. Yeah, this, ignore that. This right here is that. I could just do that twice, raise the second power. This we could do by just considering the 20. I don't need to. Okay, so anyway, so I'd have 300 minus, well, 0.2 $108. And what is that going to be? 192. So you get the same result, no matter which way you look at it. There you go. There you go. Okay, sorry about the confusion there. Do I want to redo the whole video just to fix that? No, I do not. All right, if you have any questions, of course, you guys know how to reach me. Thank you very much.